Hi everyone, welcome back. Today we're doing counting words with given prefix. We're given an array of strings words and a string prefix, and we have to return the number of strings in words that contains pref as a prefix. So a prefix is strictly at the front of the word, so we can't just do a simple check if this prefix exists in the words. If this prefix happens to be at the back of the word, that is not counted, so we have to be careful about that. A prefix of a string s is any leading contiguous substring of s. So if the prefix is at, in this case we count the at in attention, and we count the at in attend over here. So in this case, there's two words that has the prefix, so we output 2. In this case, code, that's 0 because none of the words over here starts with code. So that's pretty much it for the two test case. For each words in this list, the range will be from 1 word to 100 words, and every single word and the prefix length would range from 1 to 100. And fortunately for us, the words and the prefix consist of lowercase English letters. So that's pretty much it. So what we can do is do string slicing to get the prefix of every single word. And if it exists, we will, if the prefix of the words is equivalent to this, then we will increment the prefix count by 1. So let me quickly articulate what I mean by that. So we can get the pref length. Let's set this to be equal to the length of prefix, and we will iterate through every word in words, and we get the word pref. We'll set this to be equals to word, and we will slice it to the pref length. So if the word in this case is actually shorter than pref length, this expression is still safe and would just return the entire word itself. But if we do a simple prefix count and set this to 0, and if word pref is equals to pref, then we will just increment prefix count by 1. And that's pretty much our approach for this question. So to show how this would work, let's set this to be our test case, and the pref will be equals to 80. In this case, the prefix count is equals to 0. The pref length in this case would be the length of pref. So in this case, the pref is 80. So this would be of length 2. Pref length will be equals to 2. For word in words, let's go through and set the word to the first word, which is pay. And word pref in this case would be word sliced to the length of pref length. So in this case, that will be 0 to 1. Pref length is exclusive, so this will give us word pref equals to PA. PA is not equals to 80, so this will evaluate to false, and our prefix count stays at 0. Let's change it to attention. The word pref in this case would be 80, and 80 is equals to 80, so this will be true, and we will add prefix count by 1, giving us prefix count equals to 1. Then now we go to the third word. In this case, the word pref would be PR, and this will evaluate to false because word pref is not equals to pref. PR is not equals to 80, so this will be false. Our prefix count remains unchanged, and finally we will put word to be the last word in words. In this case, the word pref is 80, so this expression on line 12 will evaluate to true, and we will increment prefix count by 1, giving us prefix count equals to 2, and we return 2. So the answer is 2 over here. So that's pretty much our approach. Let's code it out. So now let's set the prefix count to be equals to 0. Our prefix length will be equals to length of pref, which is passed to us in this function over here. And we will start iterating all words in words. So let's get the corresponding word prefix for this current word. Let's set this to the string slice of 0 to pref length. And if word pref is equals to pref, then we will increment prefix count by 1, else we'll return prefix count. And that's pretty much this algorithm. Because we trace this should be right. So let's submit this. And there we go. In this case, if we let n to be the size of words, then, and we let pref m to be the length of pref, in this case, on line 26, we iterate through all words, so this will be on. And on line 27, we do some string slicing, and the string slicing runtime would scale linearly with respect to pref length. So in this case, this would be om as well. So in this case, line 29 to line 30 is O1, string comparison and prefix increments is O1. So in this case, the time complexity will be ONM, and the space complexity in this case, we use constant time memory here, constant time memory here. In this case, this would use OM, because if your prefix is longer, then the memory that's used on line 28 to store the corresponding word prefix for every word would also scale linearly with OM as well. So in this case, this will be OM, and we don't use any other memory that scale with N or M over here. So the space complexity over here will be OM. And that's pretty much it for this question. If you find this useful, please give us a like and subscribe, and we will see you in the next video.